In example 4, we're going to look at a real-life application of how to use this trigonometry to solve real-life problems. So a competitor in a triathlon is running along the course as shown. Determine the length in feet that the runner must cover to reach the finish line. So here's our picture. And we got a little runner dude right here. And he's going to follow these green arrows down that track. And so we know that if you were to make a triangle, we know this distance here is 200 feet. And we know the angle this makes is 63 degrees. So we want to know how long or how far he actually ran. So the first step I like to do with word problems is write down what I know. And I know theta is going to be 63 degrees. And I know that the opposite side is 200 feet. And I know that because that's the side opposite from my angle. And I know my hypotenuse is going to be x. And I know this because it's opposite from the right angle. Now let's talk about the adjacent side, which is this side right here. Well, I actually don't know anything about that, so I'm going to go ahead and write down unknown. So I know about the opposite, and I know about the hypotenuse. So if I write down SOHCAHTOA, I have the opposite, and I have the hypotenuse, so I'm going to use sine. So I have sine of theta is equal to opposite over hypotenuse. And my theta in this case is 63 degrees. And my opposite is 200. And my hypotenuse is x. So now in order to solve this now, I'm going to multiply both sides by x. And I get x sine of 63 is equal to 200. So then I divide both sides by sine of 63. And this will reduce off here. So I get x is equal to 200 divided by sine of 63. And now all I have to do is put that in my calculator. So we have 200 divided by sine of 63, and I get 224.46. So x is approximately 224.46, and we're going to round to the nearest tenth. So I get x is approximately 224.5 feet. All right, on your own now, I want you to try this one. Suppose a competitor in the swimming portion of the race is swimming along the course as shown. Determine the distance the competitor must swim to reach the shore. So we have this 48 degrees right here, which is our theta, and we want to find this value of x. So go ahead now and give that a try. All right, let's give it a go. So I'm going to first label what I know. I know my theta is 48 degrees. I know my opposite is going to be x. I know my adjacent is 75 because it's right next to the angle. And my hypotenuse is unknown. I don't know anything about the hypotenuse, which is this piece here. So because I have opposite and adjacent, let's determine which trig function I'm going to use. Well, I don't know anything about the hypotenuse, so these are out. So I have to use tangent. So I get tangent of 48 degrees is equal to opposite over adjacent. So x over 75. Then you multiply both sides by 75. You get 75 tangent of 48 degrees is equal to x. And then all you have to do now is put that in a calculator. So 75 tangent of 48. And you get 83.29. So x is about 83.29. So I'm going to round that, and I get x is about 83.3 feet.